Question 1. Which of the following could represent the graph of y equals negative x squared plus 1? So let's have a look at the options quickly. Option A, that's a straight line. This one is in the form y equals mx plus c. C is the y-intercept and m is the gradient. Okay. Let's look at part B. Okay, a graph that starts sort of from the left-hand side, very close to the x-axis, very low or very small value, rising up, going through 1 on the y-axis, and then rising at a very sharp rate. On the right-hand side there, this one is an exponential function. So this one's really of the form y equals a to the power of x, where a is in fact a number greater than 1. Okay, so this one's an exponential. Part C, okay, sort of a U shape, okay, that's a parabola. This one's concave down, so that means that there's a negative involved. Okay, this one is of the form y equals ax squared plus c. Now, the value of a here determines whether it's concave up or concave down. So in this case, okay, it's concave down, so it's actually going to be a negative number. Okay, so it's actually negative x squared plus c. C is the y-intercept, and we can see that the y-intercept here is 1. So it's y equals negative x squared plus 1. So it's option C. But let's have a look at option D, just for completeness. This one, a graph that sort of has 2 branches there, that sort of gets close to the y-axis, doesn't quite touch it, or gets close to the x-axis but doesn't quite touch it. So we call that asymptotic, or sort of approaching an asymptote. This one is a hyperbola, okay? And this one's of the form y equals k on x. Okay, so you might recall having seen these. So it's option C. Question 2. What is 0.002073 expressed in standard form with 2 significant figures? So I'm going to show you 2 different ways of doing this. Standard form just means scientific notation. So that's times, sort of this number times 10 to the power of something. Let's do it without a calculator first. What we need to do is just move the decimal point a certain number of places, actually move it enough places so that it's in front of the first non-zero number. So that's in front of the 2 here. So what we're going to do is just going to write the number first. So it's good to learn some of these non-calculator strategies. Okay, so we're going to move it 1, 2, 3, so 3 places. And so we're going to write the number with the decimal point now that's been moved, which is now going to be 2.073. Okay, we move the decimal point there, multiplied by 10. Now, because we're making a very small number, or a small number into a bigger number, okay, 0.002 is much smaller than 2.073, we need to put a minus sign in front. And the number that you put behind the minus sign corresponds to the number of places you've moved the decimal point. So 1, 2, 3, done. Okay. Now, we haven't quite answered the question. We still need 2 significant figures. So now we need to round our answer, or our number in scientific notation. 2 significant figures means starting from the first non-zero digit, which obviously here is the 2. So it's going to be 2.0 or 2.1. So what I like to do is I just like to underline the numbers that I want, the significant numbers, which means they're the important numbers. Okay, so that's going to be 2 point. Now, the 0 either stays as a 0 or becomes a 1 depending on the number behind it. So the number behind is a 7, which means that the 0 must become a 1. We then ignore the 7 and the 3. We don't need to worry about those. Times 10 to the power of negative 3. So that's going to be option D. Okay, so 2.1 times 10 to the negative 3. Now, how could we do this using a calculator? Your calculator can do sort of work in scientific notation and also round to a certain number of significant figures as well. So what we'll do, I'll just move the number there, make sure that number's visible. First of all, mode, actually it's shift setup, and well, it's actually the mode key, but we've got to press shift first. Number 7, or at least on this calculator, it's number 7, SCI, so that means scientific notation. So push that. Now, the next question that it asks you is how many significant figures, that you would like, and then we want 2 significant figures. So press 2. Now type in the number 0.002073 and there's your answer, 2.1 times 10 to the negative 3. So very nice. The one thing that you need to remember to do is to take it back out of that mode. There's two ways of doing that. Probably the fail-safe way of doing that is do a factory reset on the calculator. So shift, number 9, clear, all, reset all. So just basically follow the prompts, equals, and we're back out of that SCI mode. Question 3. The distance between Bricktown and Koala Creek is 75 kilometers. A person travels from Bricktown to Koala Creek at an average speed of 50 kilometers per hour. How long does it take the person to complete the journey? So this is a question that relates to distance, speed and time, and you probably might have seen this before. Remember well, if you haven't seen it, well, good way to sort of introduce it, I guess. Distance, speed and time. You might have seen this triangle before. So what this means is that distance is equal to speed multiplied by time. So we want how long. So this means that we want time. So the way this works is if you cover the t, okay, so imagine you cover the t, t is equal to distance over speed. Okay, so time is equal to distance over speed. Now the distance is 75 kilometers over a speed of 50 kilometers per hour. Okay, so 75 divided by 50 and we get 1.5. Okay, and 1.5 hours means 1 hour and 30 minutes. Okay, so it's going to be option C. Question 4. Joan invests $200. She earns interest at 3% per annum, compounded monthly. What is the future value of Joan's investment after 1.5 years? So this is a lump sum investment, so just investing sort of a bit of money all at the beginning. This is the future value formula. So future value is equal to present value multiplied by 1 plus R, the interest rate per period, to the power of n, which is the number of periods. Now, PV, so that's the present value, is 200. 1 plus, now what's the interest rate? Interest rate's 3% per annum. So let's write down 3%, but it's compounded monthly, which means that we need to divide that by 12. Okay, and it's for 1.5 years. Now, is that to the power of 1.5? Now, just be very careful here. Initially, it might appear so, but it's compounded monthly. So I would probably underline that, make sure you're clear on that. There are 12 months in a year, all right, 1.5 years. Okay, if you times that by 12, you've got 18 compounding periods in total. Okay, so always remember it's interest rate per period to the power of the number of periods in total. And in 1.5 years, there are 18 compounding periods. All right, entering in all of that into the calculator. Okay, 1 plus R. So you can actually type it in as is. That's the beauty of these calculators. They're they're really versatile in this way. So power of 18, and we get $209.19, and that would be option B. Question 5. A plant stem is measured to be 16.0 centimeters, correct to 1 decimal place. What is the percentage error in this measurement? Now, the first thing we need is the precision. Okay, so how precise is this measurement? And that sort of goes by the number of decimal places, or just looking at the measurement there, we can see that the most precise measurement that we could make is in fact the smallest unit, which is 0.1 centimeters. That comes from the fact that it's 1 decimal place. The next unit up, or the next measurement up from 16.0 is 16.1, then 16.2. So that gives you an indication of how precise the measurement is. Now, the next thing that we need is the absolute error, which is half the precision. So that's going to be half times 0.1 centimeters, which is 0.05 centimeters. Now, the last step, so I'll put this as steps. So step 1, precision. Step 2, absolute error. Step 3 now is the percentage error. Okay, is equal to the absolute error, 0.05, over the measurement itself, which is 16.0, and we multiply that by 100 to turn that into a percentage. So let's do that. Okay, 0.05 over 16.0, multiply that by 100 to turn it into a percentage, and we get 0.3125%. So 0.3125, option A. Question 6. Suppose y equals -1 minus 2x. When the value of x increases by 5, the value of y decreases by, and we have some options there. So I think the first thing to notice is that the equation really is in the form y equals mx plus c. Okay? In fact, I might just rewrite it a little bit differently here. I'm just going to rearrange it just so you can see what's going on. Okay, so I'm going to put the -2x first and then -1. So the gradient's -2. So what does the gradient represent here, or what does it mean in terms of the values of x and y, or that relationship between x and y? -2, this gradient means that when x goes up by 1, y goes down 2 places, or by 2. X goes up by 1, y goes down by 2. So if x is increasing by 5, that means y is decreasing by 10. In fact, the -1 here has nothing to do with it at all. If we're just talking about x changing in a sort of by a particular quantity, y will change accordingly, but multiplied by whatever the gradient is. Okay, so the answer is 10. Now, just for your benefit, if you just want to see this a different way, you could actually do a table of values, in fact, and you could probably see this fairly quickly, in fact. So x, y, and let's try some values here. So 0, 5, and 10. And we can use substitution here. So when x equals 0, substituting it into the original formula here, -1 minus 0 is -1. When x equals 5, okay, so we have -1 minus 2 times 5, we get -11. Whoop, I'll just put that on the screen there. Yep, -11. Okay, and when x equals 10, we get -21. So x is going up by 5, y is going down by 10. So that's another way to be able to see the answer. Question 7. Which histogram best represents a data set that is positively skewed? So that's a distribution that has a, what we call a tail. So it seems to be sort of very long on one side of the distribution. So if you have a look at A, okay, the bulk of the distribution is on the left-hand side, but there's a tail region on the right. Option B is the other way around. So you got the tail on the left, okay, so it sort of looks like that, and we don't want that because that's negatively skewed. So it really goes by where the tail is, or the position of the tail. C is somewhat symmetrical, okay, and D is sort of somewhat uniform. So it's option A. Question 8. John recently did a class test in each of the 3 subjects. The class scores on each test were normally distributed. The table shows the subjects and John's scores, as well as the mean and standard deviation of the class scores on each test. You can see the table there, have a quick read of that. So relative to the rest of the class, which row of the table below shows John's strongest subject and his weakest subject? So this is a case of Z-scores. So how do we know it's Z-scores? Well, we're told that it's normally distributed. As soon as you see that, you know it's going to involve something to do with the bell curve normal distribution, Z-scores, all that sort of comes into it. Okay, so the higher the Z-score, the further along, or the higher, maybe think of it in terms of rank or strength, the subject would be for John. All right, so let's work out each one of these. So the Z-score formula, and this will be on your formula sheet, but I'm just going to write it here. So Z is equal to X, so the score, minus the mean, okay, over the standard deviation. All right, so using that, let's work out the Z-score for each one of these subjects. Okay, so the first one, French, so that's 82, Okay, so using the z-score formula, minus the mean, so 70 over the standard deviation of 8, and we get a z-score of 1.5. So z equals positive 1.5. So I like to put the plus sign there, so I know clearly it's a positive z-score. Yeah. Now, commerce. Okay, so let's do the same thing. Okay. Yep. All right, so John score 80 minus the mean over 5, and we get a z-score of positive 3. In fact, positive 3 is fantastic. That's a great z-score. that's well ahead. All right, and music, 74, mean of 50, standard deviation of 12. Okay, so relative to the mean, okay, and might just 74 minus 50 over standard deviation of 12, and this is a z-score of 2. Positive 2. So looking at these z-scores, the lowest z-score, even though it's a positive z-score, it's above 0, we're talking relative. So we're talking compared to each other. French is the weakest subject. Okay, so it's either going to be this one or this one here. So it can't be B and it can't be D. Okay, so out of A and C, the strongest subject is commerce. So it's going to be option A. Question 9. Team A and Team B have entered a chess competition. Team A and Team B have 3 members each. Each member of Team A must play each member of Team B once. Which of the following network diagrams could represent the chess games to be played? Okay, so this one, probably best to sort of visualize what's going on here. So if we had, let's say one of the players, let's say Team A, player 1. So this represents one of the vertices. Okay, so one of these dots. That player has to play one game with each of the players from Team B. So let's call that Team B player 1, Team B player 2, and Team B player 3. Now, let's go back to vertex A1. So this is Team A player 1. Think about the degree of this vertex. The degree is the number of edges that basically enter or sort of leave a vertex, or the number of edges connecting to a vertex. And the degree here is equal to 3. Now, go back to each of these options. Let's have a look at option A. The degree of each of these vertices is 2, so it can't be A. Option B, each of these vertices has degree 3, so it's in fact option B is in fact the answer. But let's have a look at option C and D quickly. The degree of each of the vertices in option C is 4, so it can't be C. And option D, well, you've got a player here playing 1, 2, 3, 4, 5 games. That's not going to work. Okay, so it's option B. Now, if I wanted to label each of the vertices with the team and player number, that could be A1. Okay, and A1 is playing B1, playing B2, and also playing B3. Okay, A1 does not have to play obviously A2 or A3 because they're on the same team. Likewise, A2, okay, can play B3, player A2 can play B2, and player A2 can play B1. And this leaves us A3 here, where, so player A3, so team A player 3 can play team B player 1, team B player 2, and team B player 3. Question 10. A plumber charges a call-out fee of $90 as well as $2 per minute while working. Suppose the plumber works for T hours. Which equation expresses the amount the plumber charges, so that's C dollars, as a function of time, T hours? Now, let's go back to the question. Plumber's charging $2 per minute. Now, but T's in hours. So we need to convert this $2 per minute, okay, per minute into dollars per hour. So there's 60 minutes obviously in an hour. So if we multiply that by 60, we end up with $120 per hour. Okay, so for every T, every increase of T by 1, so an extra hour worked, it's an extra $120. Okay, so looking at the options there, we're charging $90, so that's just an upfront charge. So it's going to be 90 plus something. Okay, so 90, this 90 is not dependent on the amount of time that the plumber works. So the 90 and the T cannot be together. So it can't be A and it can't be C. Now, let's look at option B, 90 plus 2T. T's in hours. So if the plumber works 1 hour, the plumber charges then $2. So that doesn't make any sense. But we've done some work previously to show that $2 per minute is really the equivalent of 120 per hour. And that leaves us option D as our only viable option. In fact, the correct option. Okay. Question 11. An asset is depreciated using the declining balance method with a rate of depreciation of 8% per half year. I might underline that. The asset was bought for $10,000. What is the salvage value of the asset after 5 years? So I think underlining the half year here is very, very important. So it's 8% per half year, that's like 16% per year. However, we need to keep it in terms of the length of the period that's mentioned, which is a half year. So salvage value of the asset after 5 years. So how many half years is that? That's going to be 10, isn't it? So salvage value, okay, so it's going to be V is equal to V naught. Okay, so that's the original value outside of 1 minus R to the power of N. So that's the formula. Okay, let's substitute in some numbers. Okay, it was $10,000 was the original purchase price. 1 minus, now it's 8% per half year to the power of the number of half years that we have. There's going to be 10 of them. All right, so substituting that into calculator, 10,000 outside of 1 minus 8% to the power of 10, and we get 4343.88. So it's going to be option C. Question 12. For a set of bivariate data, Pearson's correlation coefficient is -1. Which graph could best represent this set of bivariate data? Now, it helps to know some of your correlation coefficients. Correlation coefficient of 0 means no correlation whatsoever, and it looks like a cloud of dots. But when there's a pattern there, if it's an upward trend, it's a positive number for the correlation coefficient. If it's a downward trend, then it's a negative number. So given that it's -1, and -1 is the absolute sort of least in terms of the number that it can be, and -1 implies a perfect negative correlation. In other words, all the points will lie on a straight line. And it looks like option D is the perfect candidate. And option D, it is. Now just quickly, option C would be a correlation coefficient of +1. Option B would probably be around probably 0.75, -0.75 actually, because it's downward. And A would probably be +0.75. So moderate to strong. Okay, so anyways, answer is D. Question 13. When Jake stops drinking alcohol at 10:30 p.m, he has a blood alcohol content, BAC, of 0.08375. So I might actually just underline that. The number of hours required for a person to reach 0 BAC after they stop consuming alcohol is given by the formula time equals BAC over 0.015. At what time on the next day should Jake expect his BAC to be 0.05? So what we're interested in is just how much time or how many hours it's going to take rather than dropping to 0. So in other words, 0.08375 to 0, just dropping to 0.05. So let's work out the drop first. So 0.08375 minus 0.05. Okay, so let's enter that in there in the calculator. 0.08375 minus 0.05. So we get I might just write this down, 0.03375. So we want to work out how long it's going to take Jake's BAC basically to drop to 0 from this level here. Right, so now let's use the formula. So time is equal to 0.03375 over 0.015. Okay, so 0.03375 over 0.015, and we get 2¼ hours. Okay, so if you want to press the degrees, minutes, seconds button, 2 hours and 15 minutes. So what time in the morning is that? So stops drinking at 10:30 p.m. and we're going to add 2 hours and 15 minutes. So that's going to be, well, 10:30 p.m. Plus 2 hours and 15 minutes. It's going to be 12:45 in the morning. So option A. Just quickly, if you ever get stuck and you think, oh, how did you work that out? You know, quickly, 10:30 p.m. Right now, if you want to, you could use 24-hour time. Okay, so I might just write that up here. Right, 22:30. Okay, plus 2 hours and 15 minutes, so that's 0215. Okay, if you add those together, 22 hours 30 minutes, so that's 10:30 p.m. plus, okay, 2 hours and 15 minutes, we get 24:45. Well, 24 hours means we've gone into the next day. If we subtract 24 from that, we get 0:45. So that's midnight, 45 minutes past midnight. Question 14. An annuity consists of 10 payments, each equal to $1,000. Each payment is made on the 30th of June each year, from 2021 through to 2030 inclusive. The rate of compound interest is 5% per annum. The present value of the annuity is calculated at the 30th of June 2020. The future value of the annuity is calculated at the 30th of June 2030. Without performing any calculations, which of the following statements is true? Now, future value of the annuity is calculated at the 30th of June 2030. There's our first clue. And that's the end of the investment, basically the investment term, right? So it's a 10-year term. So clearly, the future value should be the greatest. In fact, logic would tell you so. So it can't be C and it can't be D, because this is implying that the present value is in fact the largest, or the largest amount. Now, the present value of the annuity is calculated at the 30th of June 2020. So 30th of June 2020, each payment is made on the 30th of June each year from 2021. So the present value of the annuity is actually nothing. It's actually the least. So it certainly can't be B, that's for sure, because $10,000 is the value of the principal or the amount invested over that 10-year period. After all, it's $1,000, isn't it, per year. So it can't be B, logically. In fact, the only other option is A. Present value of the annuity, 30th of June 2020, there's nothing in there, assuming that there's no installments or no payments had been made. So starting from a zero bank account, and then the first installment or the first contribution of $1,000 does not occur until the year after. So A would have to be the answer there, and in fact, logically, it is the correct answer. Question 15. The top of a rectangular table is divided into 8 equal sections as shown. A standard die with faces labelled 1 to 6 is rolled onto the table. The die is equally likely to land in any of the 8 sections of the table. If the die does not land entirely in one section of the table, it is rolled again. A score is calculated by multiplying the values shown on the top face of the die by the number shown in the section of the table where the die lands. What is the probability of getting a score of 6? So first of all, we have a 1 on 8 chance that the die will land in any of these 8 squares. So which of the squares are we interested in? we want a score of 6. So whatever number's on the top of the die, multiply it by the number on the square that it lands, that's the score. So if we want a score of 6, okay, we need the die to land either here. Okay, so we need to roll a 6 here. So I might just put a 6 there. We need it to land here, or that's one of the other options. We need to get a number 3 rolled on the die there. The die could land on the 3 square, but the die itself would have to have a 2 on it, since 2 times 3 is 6, obviously. 4 and 5 don't count. Well, we can't get 6 by multiplying the number on the die by 4 or 5. The only other one is 6, okay? And we have to roll a 1 on the die there. So what's the probability in total? Now, the die is a fair die, so you have an equal chance of rolling a 1, 2, 3, 4, 5 or a 6 on the die, and you've got an equal chance of also landing in one of these 8 squares. So, in fact, we've got 1, 2, 3, there's 4 probabilities here, okay, so it's like a multi-stage or a 2-stage event here. There's 4 different outcomes here that we're looking at, okay, and, well, multiplying those two together, okay, you have, let's say the die lands on the first square. We have a 1 in 8 chance, okay, of landing there, times a 1 in 6 chance of rolling a 6. Now, the same thing also occurs for square number 2. You have a 1 on 8 chance of landing there, multiplied by a 1 on 6 chance of rolling a 3. And likewise with this square here and this square there. So we've actually got 4 of these basically equally likely outcomes of landing on a square and rolling a particular number. Okay, so, or that event, should I say, is probably the better word to use. The event of landing on a particular square and rolling a particular number. Okay, now multiplying all that together. Okay, so make sure we do this properly. So 1 on 8, okay, multiplied by 1 on 6, and multiply that by 4, and we get 1 on 12. Okay, so it's option B. The other way you can do this, okay, so is you can draw a tree diagram, perhaps. Okay, there's actually, just sort of that's the other way, I guess, and if maybe there might be other ways too, I don't know, but this is probably the easiest. If you want to do a tree diagram, you could do it this way. So 1, I have to do it a little bit larger, 2, 3, 4, 5, 6, 7, 8. Okay, each of these is a 1/8 chance. Okay, these are the squares. Okay, one of the 8 squares, and so on. Now, there's only 4 that we're interested in. 1, 2, 3, 4. Okay, so, and we need to either roll a 1, a 2, a 3, or a 6. 1, 2, 3. Now, you can see that drawing the tree diagram is going to be too messy. Now, that's one of the reasons why I just wanted to show you this, to think, well, if you've gone the tree diagram way, you'd probably hit a dead end at this point. And you probably think, nah, this is getting far too messy. You could probably do it, actually, and there's enough space on this page to do the tree diagram. But I think it's far easier to think of it as like a compound event or a compound sort of outcomes, where you know the probability of landing on a square, and you also know the probability of rolling a particular number, and the two outcomes are multiplied together to give you the probability of that particular event. Question 16. Consider the triangle shown. Find the value of theta correct to the nearest degree. So first of all, let's classify the type of triangle. It's a right angle triangle. We're not going to need the sine rule or the cosine rule. Okay, so just regular right angle trigonometry, SOHCAHTOA. What I'm going to do is I'm going to mark in theta first of all, just mark it in a little bit clearer by just drawing the arc in, just to make it apparent where it is. So I can mark in also the various sides. This is the opposite side. This would be the adjacent side. Since it's closest to theta, this would be the hypotenuse. So I'm also going to write SOHCAHTOA here. Okay. I've got opposite, adjacent, 2 known sides there. It's going to be 10. So tan of theta is equal to opposite over adjacent. Okay, so that's going to be 8 over 10. All right. Now, we need theta to be the subject of the formula there. And we're going to move tan to the other side by using the inverse of tan. So this is tan to the -1 using the shift key on the calculator, and then before we press the tan button. 8 over 10. And let's enter that in now. So shift tan, 8 over 10. And we get 38.659. Okay, 38.659 ... but we need the answer to the nearest degree, so that'll be 39 degrees to the nearest degree. Now part B says find the value of x correct to 1 decimal place. Now, being a right angled triangle and we have 2 known sides, there's 2 ways we can do this. Either we can use trigonometry again, and we could use cos or sine or whatever, actually whichever one you like. You got all 3 sides. Well, you got 2 sides known. Actually you've got an angle. So you could use, in fact, you could use sine or cos, but why bother? You've got 2 known sides, 2 of the shorter sides. Why don't we just use Pythagoras' theorem? It's just a lot easier. So you've sort of got a choice here. So by Pythagoras' theorem, okay, x squared is equal to 8 squared plus 10 squared. Okay. All right. So 8 squared plus 10 squared, 164. All right. And we need to take the square root of that. So x is equal to square root of 164. And that gives us 12.806. Okay. But we want it correct to 1 decimal place. So that's going to be 12.8 correct to 1 decimal place. Question 17. Ayla wishes to estimate the number of trees on a square block of land measuring 1,000 metres by 1,000 metres. She counts the number of trees on a 5 metre by 5 metre section of the block and finds there are 8 trees. Based on this, estimate the number of trees on the entire square block of land. So I might just draw a quick diagram here to sort of help you visualise what's happening here. So just imagine, okay, there's our and sort of, it's a very large block of land, of course, but there's our 1,000 metre by 1,000 metre block of land. So the question is, in a 5 metre by 5 metre block or a square, so that's our 5 by 5, we have 8 trees. So the question is, how many of these 5 by 5 blocks of or squares of land are contained within this 1,000 metre by 1,000 metre sort of large block of land? Okay, and we could work that very easily just by using area. Okay, so area of the large block of land is 1,000 by 1,000. We're going to divide that by the area of the small block of land, that's the small square, so this square here. Okay, and that gives us, okay, how many, now I'll break this up into sort of 2 calculations instead of doing it all in the one. So 1,000 times 1,000 divided by 5 by 5, and we get 40,000. So 40,000 of these, okay, of these 5 by 5 sort of small squares will fit in 1,000 metres by 1,000 metres. Okay, that's a square kilometre. That's a very large, very large tract of land. Now, how many trees are there? In a 5 by 5 square, there's 8 trees. So the number of trees is equal to, we've got 40,000 squares of those 5 by 5 metre squares. Each one has 8 trees in it. Or so the estimate, therefore, now I should say more accurately that it's the number of trees is really an estimate. Okay, so 40,000 times 8, and it's 320,000 trees estimated. Question 18. The diagram represents a network with weighted edges. Part A, draw a minimum spanning tree for this network in the space below and determine its length. So to answer this question, I'm going to use Kruskal's algorithm. I find Kruskal's algorithm to be simpler than Prim's algorithm in terms of implementation. We just choose the edges in ascending order, ensuring that as we choose these edges, I'm going to highlight them actually, that we're not introducing any closed paths or cycles. So let's have a look at the edges just by inspection. The lowest weight edge is GH. So I might just highlight that. And the next highest edges in weight are weight 2s. So we have the FGs, FH, we've got FD, we have FC, we've got ED and AB. So that's sort of the next highest weight, okay, up from 1. So I might highlight FG, okay, FD, FC. Now we can't highlight FH because that would introduce a cycle, cycle FGH. Okay, so we've just got to be careful with that one. So we can't highlight that. We can highlight ED, certainly can do that. And it's still a tree, okay, it's not yet spanning. We've got AB as well, okay. So that's all the edges of weight 2 that we can highlight without introducing a closed path. Now let's have a look at the next highest weight edges. So up from 2, we have edges of weight 3s. So we can't choose CD because that'll introduce a cycle, okay. We can either choose BE or we can choose BC. There's multiple answers to this, okay. So there's probably, there's several, there's probably more than 2, but the minimum weight will be the same though, okay. So I'm just going to choose BE, and that is now a spanning tree. So spanning means all the vertices are now connected, and it's a tree because there's only one way to go from any one vertex to any other vertex that we choose, okay. So drawing the minimum spanning tree, okay, so all the highlighted edges I'm going to draw here. So it doesn't have to be to scale, but I'll just try and draw it as neatly as possible. Okay, so E, we have a D here, F somewhere here, okay, and C's up here somewhere. Again, doesn't really matter, as long as you try and keep it neat and tidy, of course. Okay, and we got H there. All right, now something else, just to sort of make sure that, well, one way to kind of make sure that you've done the right thing is if you count the number of vertices, let's count them, 1, 2, 3, 4, 5, 6, 7, 8 vertices, there should be 7 edges. 1, 2, 3, 4, 5, 6, 7, okay? So that's one of the rules of a minimum spanning tree, or one of the, I guess, conditions or one of the characteristics is that if you count the number of vertices, if it's a minimum spanning tree, there'll be 1 less edge. So if there's 10 vertices, there'd be 9 edges. If there's 4 vertices, there'd be 3 edges. That would be the number of edges needed to connect it up in a tree. All right, let's draw it in now. So AB, that's 2. And I'm going to keep a running tally here, so or just sort of write down the weights of these edges, so, and then add them up at the end. Okay, we got BE. Okay, that's 3. Okay, plus 3. So I'm just writing it there. You can't see that on the screen there at the moment. Okay, we have ED. Okay, that's 2. All right, and we got FD. Okay, that's another 2. We have CF. Okay, that's another 2. All right. And we've got FG. Yep. And that's another 2. Okay. And finally, GH. Okay. And that's a 1. Okay, so hopefully that looks correct. No, we haven't missed anything. Count the number of edges again. 1, 2, 1, 2, 3, 4, 5, 6, 7. Yep, 8 vertices, 7 edges, so I've got them all there. Now let's add them up. So 1 plus 2, 3, 3 plus 2 is 5, 5 plus 2 is 7, 9, 12, 14. Okay, so that's equal to, so I've just run out of space in this box. Okay, length, minimum length of the spanning tree is 14. Now there is a part B. Okay, so part B, 18B, the network is revised by adding another vertex K. Edges AK and CK have weights of 12 and 10 respectively. Okay, so that just means in that order. So AK is 12, CK is 10. And it's seen on the diagram here. So this is the vertex that's been added, vertex K. What is the length of the minimum spanning tree for this revised network? Now, adding an extra vertex means we have to add an extra edge. So I might just put part A back just to show you part A again. Okay, we're adding K up here somewhere. So that's vertex K sort of between A and B, or just just above vertex B in fact, right, somewhere here. And it's connecting it's connecting to vertex A and vertex C. Now, in order to ensure that it's a tree and not a cycle, we have to pick either the 12 or the 10. Now, in order to ensure that it's still a minimum spanning tree, in other words, all vertices connected, but with the minimum possible weight edges, okay, in a tree configuration, we choose this one there, okay. There's no point picking the 12. We choose the 10. There's one of the two. They're the only two options we have to connect K to the rest of the network. So the length of the minimum spanning tree for this revised network, the existing network from part A was 14, and we add 10 to that, and that gives us now a minimum weight of 24 for this revised network. Question 19. A fence is to be built around the outside of a rectangular paddock. An internal fence is also to be built. The side lengths of the paddock are X meters and Y meters as shown in the diagram. A total of 900 meters of fencing is to be used. Therefore, 3x plus 2y equals 900. The area A in square meters of the rectangular paddock is given by A equals 450x minus 1.5x squared. The graph of this equation is shown. So here it is. Okay, so you can see that it's a parabola, a concave down one. Let's have a look at part A. There's a few parts of this question. If the area of the paddock is 30,000 square meters, what is the largest possible value of x? Okay, so this is where we go to the y-axis. Okay, so let's go to the graph. Go to the y-axis. The y-axis represents area. Okay, so we want to find the largest possible value of x. So if we take a ruler, okay, and just project across, okay, so that's 30,000. So it looks like we have two answers here. X is 100, okay, 100 meters, or 200 meters. Okay, so the largest possible value of x is 200. Okay. I'm not going to mark the graph because, just in case if I need it for a subsequent part, it's only worth one mark. I don't need to show any working out. You can just read it straight off the graph. Let's have a look at part B. So just put that there. So part B, find the values of x and y so that the area of the paddock is as large as possible. Now, you can use part A to help you with this one, or at least the idea from part A. If you go back to part A, it says if the area of the paddock is 30,000 square meters, what is the largest possible value of x? Let's reverse it. What is the smallest possible value of x? And get our two values. So the 200 meters that we found here, let's find the smallest possible value of x. Okay, so I think originally I said for part A that the smallest value was 100. The largest value is 200. The vertex is in fact midway between the two, and that's going to be at 150. Okay, but we can read it straight off the graph. as well. Okay. So the vertex x equals 150 meters, and that's from the graph. Probably the easiest just to read it from the graph. But it was interesting to note that it was exactly midway between the 100 meter mark and the 200 meter mark. Okay. So if we found x equals 150 meters, we need to now find the y value. Let's go back to our original diagram. Okay, so we found x is equal to 150 meters, but we need to find the value of y. And we're going to use this equation here, 3x plus 2y equals 900, to calculate the value or to determine the value of y. Okay, so I'll just go back to part B. Okay, so 3x plus 2y equals 900. Okay, so moving ahead. Okay, so 3 times 150 plus 2y is equal to 900. Okay, so we need to solve this equation for y. So 3 times 150, okay, that's 450 plus 2y is equal to 900. Okay, I think we're getting close to our solution. If we subtract 450 from both sides, 2y is equal to 450. Okay, hence y is equal to 450 divided by 2. Okay, which is equal to 225. Okay, so therefore x equals 150, y equals 225. And part C, just for 1 mark, using your values from part B, find the largest possible area of the paddock. Well, we'll just go back to there's the diagram of the paddock there. That's 225 meters. And that's 225 meters all the way along. The internal the divider doesn't really matter in this case. It's just the area of the large rectangle. So this whole rectangle here, it's just x times y. Okay, so area is equal to xy, okay, which is equal to 150 multiplied by 225. Okay, 150 multiplied by 225, and we get 33750. Square meters as our maximum or the largest possible area of the paddock. Question 20. The table shows the income tax rates for the 2019-2020 financial year. For the 2019-2020 financial year, Wally had a taxable income of $122,680. During the year, he paid $3,000 per month in pay-as-you-go, PAYG, tax. Calculate Wally's tax refund, ignoring the Medicare levy. Okay, so I think the first thing that we can do here is calculate the PAYG tax that Wally has already paid. Okay, it's $3,000 per month, and it's times 12, so 12 months in a year. So that works out to be $36,000. Now we need to work out the amount of tax Wally owes based on the tax table. So let's say tax owed is equal to, now his taxable income is $122,680. So that's this row there. So it's between sort of above the $90,001 mark up to the $180,000 mark. And we just follow the instructions here, basically in the second column, which tells us how to calculate the amount of tax that Wally owes. Okay, so he's going to pay $20,797 plus, so plus sign there, 37 cents for each dollar over 90,000. So what does this mean? 37 cents for each dollar, in each dollar. It's 37%. So we could just write that as 37% multiplied by the difference between $90,000 and Wally's taxable income. So that'll be $122,680 minus $90,000. So we just managed to fit that in there. Okay, so let's calculate that. And so it's 20,797 plus 37%, okay, multiplied by, okay, $122,680 minus $90,000. Okay, and we get $32,888.60. Okay, so the tax refund is equal to the PAYG tax, so $36,000 minus the amount of tax that Wally owes, which is actually less than what he's paid. Okay. And it's $3,111.40. Question 21. The inflation rate over the year from January 2019 to January 2020 was 2%. The cost of a school jumper in January 2020 was $122. Calculate the cost of the jumper in January 2019, assuming that the only change in the cost of the jumper was due to inflation. So this is a question that we can answer using the future value or the compound interest formula, sometimes called the future value formula. And we're just going to write this down. So that's the future value is equal to the present value multiplied by 1 plus the interest rate. And I'm going to put the interest rate there. This is per period to the power of sort of n, which is the number of periods. But we're only talking about n equals 1. Okay, so it's just the change from one year to the next. Now this is a situation where we have the future value, 2020, okay, or 2020, it's $122. But what we want to find is the present value. So assuming, let's assume that we're in the year 2019 and we want to know what the price is of the jumper in 2020, you would use, in fact, the same formula, except you would have the present value, but you wouldn't know the future value. So we need to rearrange this formula. Okay, so I'm just going to substitute in the known values there. We don't know what the present value is. We know the interest rate per period, which is per annum. In this case is 2%, and that's to the power of 1 because we're only talking about 1 year. So let's rearrange this. So 122 divided by, because it's sort of the inverse of multiplication there, 1 plus 2% is equal to the present value. Okay, so just reversing or just sort of swapping both sides of the equation over. 122 divided by 1 plus 2%, and entering in all of this in the calculator, 1 plus 2%, and we get $119.61. So that was, or that would have been the price in the year 2019. NESA has a credit card on which interest at 17% per annum compounded daily is charged on the amount owing. At the beginning of the month, NESA owes $500 on her credit card. She makes no other purchases using the credit card, but 15 days later, she repays $250. Assuming that interest is charged for the 15 days, calculate the amount owing on the credit card immediately after the $250 payment is made. Okay? So think of it this way. At the moment, the principal's $500. Okay, so at the start of the month. And we've got 15 days worth of interest that accrues based on this $500 principal. So $500. Now we're going to add the interest, okay, and that's going to be compounded. So it's 1 plus r to the power of n, but it's 17% per annum. Okay, compounded daily. So we need to divide that by 365. And there's 15 days worth of interest on that. Okay, so assuming that interest is charged for the 15 days, so we need to raise that to the power of 15. But we want the amount owing on the card immediately after the $250 payment is made. So we need to subtract from that 250. So let's enter this into the calculator. 1 plus 17% over 365 to the power of 15. And we take away 250 since that's a repayment. And we end up with $253.50. Question 23. In a tropical drink, the ratio of pineapple juice to mango juice to orange juice is 15 to 9 to 4. Part A. How much orange juice is needed if the tropical drink is to contain 3 litres of pineapple juice? So let's go back to the original ratio. So these terms of the ratio correspond to the pineapple juice, mango juice, and orange juice respectively. So I'm just going to put just a letter there just to indicate sort of what the term corresponds to. So the P is pineapple juice. The term here, the 9, corresponds to mango juice, so I'll put an M there. And orange juice, I'm just going to put the O there next to the 4. So 15 to 9 to 4, so that's our original ratio. We have the amount of pineapple juice, so in this drink, so we do know that we have 3 litres. But we want to know how much orange juice is required. So that's the O, that's this 4 here. So what we want is the equivalent ratio. 3 litres of pineapple juice. So many litres of mango juice, we don't know what that is at this point, to orange juice. Now, I might actually just put an OR so we don't get confused. That's not a 0. Okay, so it doesn't make sense if it is a 0, so that's OR so for orange juice there. So we want to try and find the amount of orange juice, given that we have 3 litres of pineapple juice. Now, if the original term of the ratio that corresponds to pineapple juice is 15, but the equivalent ratio, it's a 3, what do we divide the 15 by to get 3? And it's 5. So we're going to divide basically every term of this ratio by 5 to get the equivalent ratio. Okay, so now we're not interested in the mango juice, we only want the orange juice. Okay, so 4 divided by 5 gives us the amount of orange juice. Okay, and 4 divided by 5 should give us 0.8. Okay. Or 800 millilitres. Okay, either way, they're both correct. Okay, since the original unit of measure there is litres, we should be answering in litres and just keep it in litres. Okay, so I'm going to just remove this last answer there. Okay, so I think it's very important that we keep the answer in the original unit of measure there. Let's have a look at part B. The internal dimensions of a drink container in the shape of a rectangular prism are shown. To completely fill the container with the tropical drink, how many litres of mango juice are required? So I think the first thing we need to work out here is what's the volume of this container. So maybe we'll work that out first. Okay, and it's a rectangular prism, so we just multiply all the dimensions. So 40 times 20 times 35 centimetres. So 40 times 20 times 35, and we get 28,000. That's cubic centimeters. So that's equal to 28,000 milliliters, which is equal to 28 liters. So that's 28 liters in total. Okay. Now let's go back to our original ratio. So this is the ratio. This is the 15 to 9 to 4. So the total number of parts, okay, is equal to 15 plus 9 plus 4. Okay, so it's 15 plus 13, that's equal to, there's 28 parts. Okay. Now that's quite convenient because it's 28 litres, okay, and there's 28 parts in the ratio. So the value of one part, or one share, is 1 litre. So going back to the original ratio again, the 9 represents the amount of mango juice. So there are 9 parts of mango juice. Okay, so 9 times 1 is equal to 9 litres, therefore 9 litres of mango juice is required. Question 24. There are 2 tanks on a property, tank A and tank B. Initially, tank A holds 1,000 litres of water and tank B is empty. Part A. Tank A begins to lose water at a constant rate of 20 litres per minute. The volume of water in tank A is modelled by V equals 1,000 minus 20T, where V is the volume in litres and T is the time in minutes from when the tank begins to lose water. On the grid below, draw the graph of this model and label it as tank A. Okay, so there's our grid. Okay, let's go to our equation. So this is a linear equation, so it's going to produce a straight line. The 1,000 represents the y-intercept. Okay, so basically we're looking for the term without the t, and that's our y-intercept. So I'm just going to put a mark there to represent our y-intercept. And it's losing 20 litres of water per minute. So we need another point. So let's go back to our grid. We'll just pick a convenient value of t. So let's say, I don't know, 50. And let's see how much water is in the tank at the 50-minute mark. Okay, so V equals 1,000 minus 20 times 50. And we get 0. So the tank is in fact empty at the 50-minute mark. Okay, well, after 50 minutes. So let's go put a little cross there, so a little mark to indicate that point. And we have 2 points, so let's draw in our line. Okay, so I would recommend that you use a clear ruler. Okay, so just makes it easier. You can see through it. So here we go. And let's label it as tank A. Actually, I might just put it up here. Okay. All right, let's have a look at part B. Tank B remains empty until t equals 15 when water is added to it at a constant rate of 30 litres per minute. So by drawing a line on the grid on the previous page or otherwise, find the value of t when the 2 tanks contain the same volume of water. Okay, so I think we'll just use the graph. It's probably going to be easier. Okay, so we know at the 15-minute mark, okay, tank B is initially empty and it's filling. So at the rate of 30 litres per minute. Okay, so what we need to work out is another point on this grid. So we can draw the line that represents the volume of water in tank B at a given point in time. So what we can say is, well, let's just say after 20 minutes, let's work out how much water's in tank B, and then that way we can plot our point. So, okay, so Okay. So it's 30 litres per minute times 20, which equals 600 litres. So on the grid, when T is in fact equal to 35. Okay, so this 20 minutes just means that since tank B started to fill, so it's from when tank B started filling, okay, which is from this point here. After 20 minutes from this point, tank B has 600 litres. So that's going to be at the 35-minute mark, and we'll just go to this point here, and just put a little X there, just to mark the volume, to mark the point where there's 600 litres after 35 minutes, okay, in tank B. Let's join the points. So we'll draw in our line. Okay, so that's that there. Okay, and I might just continue that along. Yep. And let's call that one tank B. All right. And to answer the question fully, we need to work out, obviously, at what point what value of T when the two tanks in fact contain the same volume of water. So that's the point of intersection. That's what we're trying to find. So it's very similar to those break-even type analysis questions where we're looking for the point where the profit equals the loss, except this is now applied to water. So this is the point that we want there. Okay, so if we project downwards, okay, so looking at the grid, the volume of water in both tanks is equal at the 29-minute mark. Okay, so from the graph, in both tanks at T equals 29 minutes. Okay, part C, using the graphs drawn or otherwise, find the value of T where T is greater than 0. So that means T can't equal 0. When the total volume of water in the two tanks is 1,000 litres. So that means that whatever's in tank A plus whatever's in tank B is equal to 1,000. And so what we'll need to do is to look at various points sort of on the grid, and this is where a ruler would come in handy as well. So let's say at the 15-minute mark, okay, we have 700 litres of water in tank A, 0 litres of water in tank B to give you a total of 700. Okay, so if you're say moving along to say the 25-minute mark, you've got 300 litres of water, okay, in tank B, and 500 litres of water in tank A. That's 800, so still doesn't get us to the 1,000 litre mark. Okay, so if you move along, in fact, in trying these various points, and you'll get to a nice convenient point here. So let's say at the 45-minute mark, you've got 100 litres of water in tank A, and you've got 900 litres of water in tank B, and that gives you your 1,000 litres. So okay, that occurs again at the 45-minute mark. Okay, find the value of T. Okay, so okay, and that's from the graph. You could solve this using algebra, but I think it's just easier using the graph. Question 25. A composite solid consists of a triangular prism which fits exactly on top of a cube, as shown. Find the surface area of the composite solid. Okay, so I think the operative word here is the word cube, and that implies that we're going to have a lot of sides that are in fact identical. So that's going to save on quite a few calculations there, instead of having to work out one side at a time. Clearly we've got the front, the back, the base, the left and the right sides are identical, okay, in shape and obviously in area. We then have a rectangle up the top and another one on the other side. So we have the left rectangle and the right rectangle. But then we have the triangular face here at the front. We also have an identical triangular face at the back. So we've actually got two of those, in fact. So planning our solution, to get the area of this triangle, because that's really where I guess a good chunk of the work is, we need the height of this triangle. We've got the base of it, that's going to be 8 centimeters, but we need the height. So I'm just going to put a pronumeral x there. Now that's 8 centimeters along the base, so that makes it 4 and 4. Okay, 4 centimeters each side. And we have a hypotenuse here of 5. So by Pythagoras' theorem, okay, the height of the triangle, okay, x is can do it all in one calculation actually. Hypotenuse squared, so square root of hypotenuse squared minus the short side squared. Okay, so square root of hypotenuse squared minus the short side squared, and we get 3 centimeters. Okay, now we can proceed to find the surface area of the composite solid. Okay, so I might just put 3 there so we have that height there. Okay, so surface area is equal to, so we've got the front face of the cube, so let's work on the cube first, then we'll work on the triangular prism. Okay, so we've got 8 times 8, and we have 5 of those. Okay, so let's count them one more time. Left, right, so 1, 2, 3, 4, that's the back, and 5, the base. Plus, we have the top triangles, so the left and right triangles. Okay, so that's going to be 5 times 8. Okay, so, and we have 2 of those. Okay, plus the 2 triangles. Okay, so that's going to be half the base times the height, half. Now, the base is 8, not 4. Okay, so I know I've got 4 and 4 there. That was just to use Pythagoras' theorem, but the base of the triangle, the whole triangle, is in fact 8. Okay, so half the base times the height, okay, 3, and we have 2 of those triangles. Okay, so entering in all of that in the calculator, 8 times 8 times 5, plus 5 times 8, we've got 2 of those, plus half times, okay, I might just put a bracket there for consistency, half times 8 times 3, and there's 2 of those triangles, and we get 424. Square centimeters. Question 26. The preparation of a meal requires the completion of all 10 activities A to J. The network diagram shows the activities and their completion times in minutes. Part A. What is the minimum time needed to prepare the meal? So let's go through and do the forward scanning exercise here. So starting from 0, so that's at the start, the 0-minute mark. Activity A takes 14 minutes. Activity B takes 6 minutes, but activity C takes 8 minutes. With forward scanning, we take the higher of the 2 numbers. So that vertex is reached at the 8-minute mark. So activity D takes 12 minutes plus 8, okay, and that takes us to the 20-minute mark. Activity E takes 6 minutes. From the 20-minute mark, that takes us to the 26-minute mark. We have a 14 here already, but we take the higher of the two numbers, or the 2 times. So I'm going to put 26 here instead. Activity F takes 10 minutes. From the 26-minute mark, that takes us to the 36-minute mark. Activity G takes 9 minutes. From the 20-minute mark, that takes us to the 29-minute mark there. But we can reach this vertex through activity H as well. So 36 plus 8, that gives us 44. Well, we have a 29 there. 44 is clearly the larger number. So we'll put 44 here instead. Now, to get to the finish, we can either go through, in fact, activity J or activity I. In fact, both have to be completed, but comparing the 2 times, 36 plus 7, that takes us to the 43-minute mark. Okay, but we're still not complete yet until activity I is completed. 44 plus 2 is 46, so that's the higher of the 2 numbers. So the minimum time needed to prepare the meal is 46 minutes. Now, part B lists the activities which make up the critical path for this network. So this is where we do the backward scanning. So backward scanning, just think of it as forward scanning, but totally in reverse. Instead of taking the larger of 2 numbers or multiple numbers, we take the smallest this time. But we're going against the flow of the arrows there, or against the direction of the arrows. So starting at the 46-minute mark, going through activity I, or back through activity I, 46 minus 2, that gives us 44. Okay. Now, 46 minus 7 gives us 39. Okay. However, to get to this vertex here, we can go back through activity H. So 44 minus 8 gives us 36. So we rub out the 39, or cross it out, and we're going to put 36 here instead. Now, going back through activity F, 36 minus 10, that takes us back to the 26-minute mark. Okay. Now, 26 minus 6 gives us 20. However, we can get to this vertex via G, so 44 minus 9 is 35. 35 is higher than 20, so I'm just going to leave the 20 as it is there. Remember, with backward scanning, if there's a multiple path or a multiple way to get to a vertex, you take the lower or the lowest of the times that you've found. 20 minus 12 is 8, so that's fine. So we can leave that there because there's only one way to get to this vertex. And then back to the start, 8 minus 8, that gives us 0. We also have 26 minus the time for activity A, 26 minus 14, that gives us 12, but 0 is clearly less than 12. So again, we take the lower of the 2 numbers. So the activities which make up the critical path for this network, okay, we've got this one here, C. Okay, in fact, I could highlight this and it might make it just easier to see. So we've got that one there. Basically, you're looking for the earliest start time or the latest start time where they're identical. So the 2 numbers are, in fact, the same. So activity D through activity E, okay, through activity F, through activity H, and then through activity I. Okay. So it's C, D, E, F, H, and I. Okay. Finally, part C. Okay. So complete the table below, showing the earliest start time and float time for activities A and G. So the earliest start time, I think that's fairly simple to fill out. So why don't we do that first? So the earliest we can start activity A is at the 0 minute mark. So why don't we do that? And just write that down. So 0 minutes. Activity G, the earliest it can start is at the 20-minute mark. Okay. Now, the float time, the way I work it out, and there's multiple ways of doing it, but I take the latest start time minus the activity time of the particular activity we're looking at. So the latest start time of the activity following the activity that we want. So I take this number here, so the bottom number after A, minus the activity time of A, then minus the earliest start time of A. So 26 minus 14 minus 0 is equal to 12 minutes. Okay, so I've just written that there, 26 minus 14 minus 0 is 12. And for activity G, okay, 44 minus 9 minus 20 will give us the float time for G. So 44 minus 9 minus 20, okay, and we'll get 15. Okay, and that's that. Question 27. The shaded region on the diagram represents a garden. The scale is 1 centimetre equals 5 metres. Part A. Use two applications of the trapezoidal rule to calculate the approximate area of the garden. So the trapezoidal rule means we're going to try to estimate this irregular area by drawing trapeziums, basically around it. And we need two applications, which means two trapeziums. So the trapeziums have to be equal height. So what we're going to do first is I'm just going to draw it in lightly. Okay, the first trapezium. So this is the first trapezium there. And then we're going to draw in the second trapezium. Now the second trapezium actually doesn't actually look like a trapezium. It looks like a rectangle, in fact. Here we go. So the two trapeziums have equal height. Now the scale is 1 centimetre equals 5 metres. So let's confirm this. Okay, so each of these squares is 1 centimetre. Okay, so there's the halfway mark there. So this is of the length of the rectangle. So 5, 10, 15, 20. So the height of the trapezium, or each trapezium, is 20 metres. Now let's work out the side lengths of this trapezium, or the length of the parallel sides. So 1, 2, 3, 4, 5. So that's going to be 25 metres. Okay, 1, 2, 3, 4. So the common side between the two trapeziums is 20 metres, and this one's going to be 20 metres as well. Okay. So now let's apply the trapezoidal rule. So the area of the garden is approximately equal to the area of the first trapezium. So we can see that the trapezium in fact overestimates the area of the garden. But that doesn't matter. That's going to feed forward into part B. So we'll get to that shortly. Okay, so the first trapezium, okay, it's half the height. So it's half times 20 times the sum of the parallel sides. So that's going to be 25 metres plus 20 metres. So that's the first trapezium plus the second trapezium. Now the second trapezium happens to be a rectangle. So you can either use the trapezoidal rule, or the area of a trapezium, or it's just the area of a rectangle, 20 times 20 metres. But let's just use the trapezoidal rule for consistency here. So half times 20 times the sum of the parallel sides. So it's going to be 20 plus 20. Okay. And entering in all of that. Okay, so we get half times 20 times 25 plus 20. Okay, and I can enter this all as one calculation, or you can work out each trapezium one at a time. Okay, and then just add them together at the end. Plus half times 20 times 20 plus 20. And we get 850 square metres. Now, part B. Should the answer to part A be more than, equal to, or less than the actual area of the garden? Referring to the diagram above, briefly explain your answer. So the answer to part A, we can see that the trapezium overestimates. Okay, so there's some area here that it includes, which is not actually part of the garden itself. Okay, so it'll be more than. Okay. More than the actual area, okay, of the garden. As the shaded area, or the shaded region, is less than the area of the trapeziums drawn in the diagram above. Okay. Question 28. Consider the following data set. So we have a 1, 5, 9, 10, 15. Suppose a new value, x, is added to this data set, giving the following. So 1, 5, 9, 10, 15, and this x added to the end. It is known that x is greater than 15. It is also known that the difference between the means of the two data sets is equal to 10 times the difference between the medians of the two data sets. Calculate the value of x. So I dare say that the difficulty in this question is more trying to unpack this last paragraph here. So let's work backwards. So we're talking about the difference between the medians of the two data sets. Then we'll consider 10 times the difference, and then we'll use that to compute the mean of the second data set, and from that we can then calculate the x. So what I'm going to do is I'm just going to label these two data sets. Okay, so let's call this data set A, and let's call this one data set B. Okay, so median of A is equal to 9. Okay, so thankfully it's an ordered set of scores. Okay, and let's have a look at the median of B. Okay, and there's 6 scores, so it's an even number, so it's going to be between 9 and 10, so it's going to be 9.5. Okay, so the difference between the medians is 9.5 minus 9, which is equal to 0.5. Okay. Now we need 10 times the difference between the medians. So we have the difference between the medians. Let's work out 10 times the difference. Which equals 5. Okay. So continuing to work backwards, it is known that the difference between the means of the two data sets is equal to 10 times the difference. Now we have 10 times the difference here. So let's work out the means of the two data sets. So the mean of data set A is simple enough to compute. Okay, and we have 1 plus 5 plus 9 plus 10 plus 15 divided by 5. Okay, so I'm not going to use the stat mode on the calculator. I think it's just quicker to just add them up manually and divide that by 5, and we get 8. Okay. Now, the mean of data set B, okay, now this one has the x in it. Let's go back to this paragraph here. It is known that the difference between the means is equal to 10 times the difference. Now, 10 times the difference is 5 between the two medians. If the mean of data set A is 8, therefore the mean of data set B must be 8 plus 5, which must be 13. Now, from that, we should be able to deduce the value of x. Okay, so all right. 1 plus 5 plus 9 plus 10 plus 15 plus x, if we divide that by 6, because there are 6 scores, so we're finding the average, and we know what the average is, so we're kind of working backwards yet again, and it's equal to 13, since we know that the mean of data set B is 13, since that's what we've deduced already. So let's multiply both sides by 6. Okay, we can add these 5 scores as well. So I'll just do this in a few steps. So 1 plus 5 plus 9 plus 10 plus 15 plus x is equal to 13 times 6, so that's going to equal to 78. Okay, so therefore x is equal to 78. And if we subtract all these numbers, look, I could just add them up first and then subtract it from 78, but I might just do this. Minus 1, minus 5, minus 9, minus 10, minus 15, and that'll give us our value of x. So 78 minus 1, minus 5, minus 9, minus 10, minus 15. And the value of x there is 38. Question 29. Yana owns a share portfolio. Details of her share portfolio at 30 June 2020 are given in the table. Okay, so for company ABC, she owns 200 shares. Dividend yield is 6% per annum, and the market price per share is $5.50. And for company XYZ, we don't know how many shares she owns. In fact, that's what the question's about, to work that out. The dividend yield per annum is 4%, and the market price per share is $6. So Yana received a total annual dividend of $149.52 from her share portfolio. Calculate the number of shares Yana has in company XYZ on 30 June 2020. So part of the $149.52 can be worked out immediately from company ABC, and we'll sort of work out what that is. We'll take it away from 149.52 to then sort of use the formula for calculating dividend yield sort of in reverse to, or basically backtrack to then find the value of the number of shares in Yana's portfolio. All right, so for company ABC, okay, the dividend, not the yield, but just the dividend itself, okay, is equal to the number of shares multiplied by the market price per share, so that's $5.50, and multiplied by the dividend yield per share, so that's 6%. Okay, so 200 times $5.50 times 6%, and we get $66. Okay, so for XYZ, now there's sort of two parts to this. First of all, to work out the dividend for XYZ, that's going to be equal to 149.52. That's the total dividend. That's both companies combined, minus what we just worked out for company ABC. So that's $66. Okay, so that's 149.52 minus our last answer, and that's 83.52. Okay, and now the number of shares. Of X, Y, Z, okay, and we're going to use the dividend yield formula. Okay, so it's going to be, now I'm going to use the pronumeral X, okay, so X, so number of shares times the market price per share, which is $6, times the dividend yield. And we know that has to equal $83.52. And if we rearrange the formula, so to make x the subject, so x is equal to 83.52. We're going to divide that by 6, and we're going to divide that by 4%. Okay, so when we move, if you recall from solving equations, if you move a term from one side of the equation to the other, the opposite operation is then applied. Okay, so 83.52 divided by 6 divided by 4%. Yep, make sure I got that right. And we get 348. So therefore, Jana owns 348 XYZ shares. Question 30. The network diagram shows a series of water channels and ponds in a garden. The vertices A, B, C, D, E, and F represent the 6 ponds. The edges represent the water channels which connect the ponds. The numbers on the edges indicate the maximum capacity of the channels. So part A, determine the maximum flow of the network. And there's a part B here. A cut is added to the network as shown. Is the cut shown a minimum cut? And give a reason for your answer. So let's go back to part A. So these two questions are definitely connected. Determining the maximum flow of the network. Now notice that it does not state to use the maximum flow minimum cut theorem. In other words, you don't have to use cuts if you're not comfortable doing so, because sometimes it might be difficult, or you may actually miss the minimum cut, because it's possible that there might be 5, 6 or more cuts that are possible in this network. So I'm going to use numerical methods here, and I can do this fairly rapidly. So I try and identify the paths from source to sink. So this is in fact our source here, okay, and this is our sink. Okay, so this is where the water's all flowing in the end. Okay, so notice we've got 350 there. We've got an edge here that's 300. There's an edge here that's 50, feeding this vertex here. So inflow and outflow is equal there. So F is maximized. The inflow to A is 350. The outflow of A is 350 in terms of the capacity at least. So A is already maximized. So let's work out the simplest possible way to get from A to F first. So we can go A, CF. Okay, and ACF, and in the path ACF, the smallest edge, or the lowest weight edge, is 50. So the weight of that, the capacity of that path is 50. So subtract 50 from everything, so that's 150. Okay, and this would be 300 then. Okay, in fact, I probably wouldn't even need to worry about that number there. Okay, anything past F. So another path that we could use that's as simple as possible, we could go A, B, E, F. Okay, so A, B, E, F. So again, we've got 75. That's the lowest weight edge that I can see in that path. Okay, so that becomes 0. And if we subtract 75 from everything, so AB, 150 minus 75, so that's 75 there. And EF, so that's going to be 225. Okay. I'm not even going to bother with this number here. So, in fact, I may actually, it's not actually of any importance in answering this question at this point. All right. Okay. Any other paths that we can see? So again, try go for the simplest possible path. So we can also do A, C, B, E, F. Okay. Or we can do A, B, D, E, F. In fact, why don't we do that? So A, B, D, E, F. Okay, we've got 75, 50, 125, 225. 50 is the lowest. Okay, so if we subtract 50 from everything, that's going to be 25. Okay, so DE, so if we subtract 50 from that, that'll make it 75. And 225, that'll make it 175. Okay, so again, let's find another possible path from source to sink. So we can go A, C, B. No, we can't use any of these anymore. There is another possible way. We could go A, C, E, F. In fact, we didn't see that before, or I didn't see that before. A, C, E, F. And we've got 150, 100, and 175. So that's 100. Okay. So if we subtract 100 from everything, okay, and that'll make it 50 there, and EF, so that'll make it 75. Okay. And I think that's it. There's no other way to get from A to F. So we've covered all the parts. If we add all those numbers up, okay, so all those capacities, 50 plus 75 plus 50 plus 100, and we get 275. Okay, so the maximum flow of the network is 275. Okay. Right, now that takes us to part B. So a cut is added to the network as shown. Is the cut shown a minimum cut? And give a reason for your answer. Well, let's work out the capacity of the cut. Okay, so remember, we've also got to cut the edges that are running sort of in the same direction. And that's sort of dependent on which vertex we're talking about. So you can see that the cut cuts the 200 or AC, and it cuts BC as well. So cutting AC, that cuts the inflow to C. Okay, so that's an inflow. If it's cutting the inflow, then you don't need to cut the outflow. So the 50 does not need to be counted. So we're actually counting the 200. We're dismissing or omitting the 50, okay? But we're cutting the inflow to D, and by cutting the inflow to D, you're also cutting the inflow to E, but we also have to cut the 75 as well. So these two numbers here, or these two weights here are important. So 200 plus 75 plus 50, and if you add all that up, so 200 plus 75 plus 50, and we get 325. Okay, now if the cut is a minimum cut, it should be equal to the maximum flow. So the cut is not equal to the maximum flow. Of 275, therefore not a minimum cut. Question 31. Mr. Ali, Ms. Brown, and a group of students were camping at the site located at P. Mr. Ali walked with some of the students on a bearing of 035 degrees for 7 kilometers to location A. Ms. Brown, with the rest of the students, walked on a bearing of 100 degrees for 9 kilometers to location B. So part A, show that the angle APB is 65 degrees. So there's our APB there. Let's mark in some information on this diagram. So we know that Mr. Ali walked on a bearing of 035 degrees, which is just 35 degrees clockwise from north. So we can mark that in there. Now, the bearing NPB is 100 degrees, so that's that bearing there. Okay, and it's obviously the difference between the 100 degrees there and the 35 degrees here, which then gives us this angle there. Okay, so angle APB, okay, is equal to 100 degrees minus 35 degrees, okay, which equals 65 degrees. Okay. Or otherwise, if you want to show a little bit more information, a little bit more reasoning, we could say that's angle NPB minus angle NPA as our reason. All right, now part B, find the distance AB. Okay. Now, just before we do that, I might just mark in the 65 degrees there. We want the distance AB, so let's just draw that in on the diagram. Okay, so just lightly with pencil. I would highly recommend that you use pencil at this point, just in case if you make a mistake, okay, you can always rub it out. Okay, so if you use pen at this point, you make a mistake on the diagram, it may ruin your diagram. All right, find the distance AB. Now, we have a non-right angled triangle. That means either sine rule or cosine rule. If it's side angle pairs or there are known side angle pairs, so an angle and an opposite side are known. Okay, so for example, this angle and this side have to be known, or this side and this angle have to be known, and so on. That's sine rule. Otherwise, if it's two known sides and an included angle, so this sort of angle in between, then it's cosine rule. And in this case, it'll be cosine rule. So let's use that. Okay, so that's going to be AB all squared, okay, is equal to 7 squared. Okay, so it's like your A squared equals B squared plus C squared minus 2BC times cos A. Right, and you get that from the formula sheet. So plus 9 squared minus 2 times 7 times 9 times the cosine of 65 degrees. All right. And let's enter that in the calculator now. So 7 squared plus 9 squared minus 2 times 7 times 9 times the cosine of 65, and we get 76.75009902. Okay, and AB would have to be the square root of that. Okay, so 76.75009902. Okay, and we get 8.76. We'll probably round it to 2 decimal places is probably sufficient for our needs. So 8.76 kilometers. So let's mark that on our diagram as well. 8.76 kilometers. All right, now part C. Find the bearing of Miss Brown's group from Mr. Ali's group and give your answer correct to the nearest degree. So this is where we need to be sort of a little bit more careful with our diagram. We actually need to add something to it as well. All right, so first of all, go back to part C there. It says find the bearing of Miss Brown's group from Mr. Ali's group. From. Now, it's a very important word. The location after the word from is our reference point. So what we're going to do is we're going to draw another north-south axis parallel to the original one. So I might just draw that in lightly. Just there. Okay, and I'm going to call this sort of north number 2. It's just sort of a parallel with the north-south axis there, number 1. That's just so we can differentiate the two ends. Okay, and what we want this angle here. Let's call that angle theta. That's what we want to try and find. That's our bearing. Okay, so Miss Brown's group from Mr. Ali's group. However, to work that out, we need this angle here. So I need this angle alpha just in there. Okay, so the angle between the north-south axis and this line AB. But in order to find that, I need this entire angle PAB. Now, first of all, part of it we can find out. So we can use parallel lines, alternate angles. So you can see there's a Z shape there. So if you follow the pencil, north, so N, P, A, and then sort of down south there, you can see it like a Z shape there. Okay, if I turn it on its side, you can probably see the Z shape now. So like that. So this would be 35 degrees here as well. Okay. So in order to find angle alpha, we need angle PAB. And we could use either cosine rule or sine rule. Since we have 3 known sides, So we can use the cosine rule. Or if you have a side angle pair, it's probably easier to use the sine rule. The cosine rule is a little bit more complicated to use and probably takes a little bit more time. So let's use the sine rule here. So we have a known angle and we have a known side now. This is the side that we found in part B. And we need angle PAB and we have a known side opposite PAB. So there's our other side angle pair there. Okay. All right. So by the sine rule, okay, and we have angle, okay, so we'll actually sine of angle PAB over, I'll go back to the diagram there. So this is our PAB over 9, okay, is equal to sine of 65 degrees over 8.76. Okay, I know I've rounded it, but there's more than enough decimal places there to get our answer correct to the nearest degree in this question. Okay, so let's find angle PAB. All right, so just rearranging the formula, sine of angle PAB, okay, is equal to 9 times sine of 65 degrees over 8.76. No. And angle PAB is equal to the inverse sine. So if you move sine over the other side, okay, 9 times sine of 65 degrees over 8.76. Okay, and let's see what we get there. Okay, so inverse sine. You can see that okay? Yep. 9 times. Okay, so sine of 65 degrees over 8.76. Close bracket. And it's 68.61, which is probably closest to 69 degrees. This is probably the one instance I would say just rounded to the nearest degree, since we're going to be working to the nearest degree anyway. And there's nothing else on the diagram that's rounded, that involves decimals. Everything else is just whole numbers. So we might as well just express PAB as a whole number. Okay, so we have PAB's 69 degrees. So this whole angle here is 69. We have part of it is 35. So let's find angle alpha. Okay, so angle alpha, okay, is equal to 69 degrees minus 35 degrees, and that equals 34 degrees. Okay, so this angle there is 34 degrees. And alpha, okay, and theta are supplementary to each other, which means they're angles on a line, which means they add up to 180 degrees. Okay, so theta, which is our bearing, is equal to 180 degrees minus 34 degrees, and that equals 146 degrees. So therefore, bearing of Miss Brown's group from Mr. Ali's group is 146 degrees. Question 32. The diagram shows a regular decagon, 10-sided shape with all sides equal and all interior angles equal. The decagon has center O. The perimeter of the shape is 80 centimeters. By considering triangle OAB, calculate the area of the 10-sided shape. Give your answer in square centimeters, correct to 1 decimal place. Okay, so let's have a look at triangle OAB. Oh, here we go, this little slice there. In fact, if I turn the exam paper around, what sort of a triangle is it? All right, this is an isosceles triangle. So we can find that angle in there. So I'm just getting you to sort of think about a strategy here, or think about a plan of attack. So finding the angle there, we can certainly do. You might think, well, okay, why would I even bother trying to find the angle? We need to find the area of this triangle, ultimately. 10 of these triangles, well, there's 10 of these triangles that will fit inside this regular decagon, and each of those 10 triangles will be identical. So if we can find the area of one of these, multiply it by 10, we found the area of this 10-sided shape. So let's narrow our focus now onto this isosceles triangle. In fact, what I might do is I might just draw it here. It's a little bit larger. Okay, it's not to scale. Okay, and there's O, all right, there's A, and there's B. Okay. Now, we know that the perimeter of the shape is 80 centimeters, so we're going to mark sort of some information on this. And there's 10 equal sides. So perimeter, so AB, is equal to 80 centimeters. Divide that by 10, okay, which equals 8 centimeters. And we could mark that on our diagram. Okay, and these are equal sides there as well because it's isosceles. Now, angle AOB, so that's this angle here, okay, this angle there. Okay, angles at a point add up to 360 degrees, so there's a little bit of geometry that's required here. So angle AOB, and there's 10 of these angles, so they're all equal angles. In fact, it says it here, right? All interior angles equal in the question. Right, that's equal to 360 degrees, and divide that by 10, and that gives us 36 degrees. Okay. Now, since triangle AOB is isosceles, right, then base angles must be equal. Right? Angle OAB equals angle OBA. So that's this angle here and this angle here. So just to sort of show you there on the diagram. Okay, angle theta. Okay. And that would be equal to, okay, I might just put it here. Okay. 180 degrees minus 36, so that's minus this angle. And we divide that by 2 to get one of the base angles. Okay, so let's do that. 180, right, so I'll get it in the right mode first. Okay, 180 minus 36, divide that by 2, and we get 72 degrees. Okay, so I'm going to mark that on the diagram here as well. Okay. Okay, so what do you think we do next? Have a think about it. We've got a side, we've got an opposing angle, so that's a side angle pair. Okay. We need the area of this triangle, so we really need just one more side, and if we can get one more side, then we can find the area of this triangle very easily, and then it's just 10 of those. Okay, so just have a think about that for a moment. Okay, so we're going to use the sine rule here. Okay, when you have side angle pairs, it's a non-right angle triangle. We're not going to use SOHCAHTOA because that only works with right angle triangles. So this is definitely the sine rule. And we need to find really one of these sides, either OB or OA. They're the same. It's like the radius of a circle, isn't it? Okay, so let's find X. Okay, so by the sine rule, okay, so we got X on sine 72. Oh. Oops, I'll just fix that. X on sine 72, yep, is equal to 8 on sine 36. Okay, I wanted to have the X first, so it sort of becomes the subject of the formula. I was going to write 8 on sine 36 first, because sometimes writing the known side angle pair sometimes can be a good strategy, but I want to solve for X, so we'll just write that first. All right, multiply both sides by sine of 72. I'll take up a little bit of extra space here. X is equal to 8 over sine 36 degrees, and we're going to multiply that by sine of 72. All right, And I'm just going to write the full decimal answer. Not a good idea to round at this point. We'll round the answer at the end. Okay, so 8 on sine 36 multiplied by sine of 72. Okay, and we get 12.94427191. Okay, so that's, might as well write. Okay, so that's what that is there. Now, we've got all known sides, all known angles. So we can use the area rule for triangles. That's the half AB sine C. Okay, so the area of decagon, okay, is equal to. Now, first of all, we need the area of this triangle first, OAB. Yep. Okay, that's going to be half AB sine C. So that's, we're going to use our area rule, half AB. So that's 12.944. Okay, 7191. In fact, we're going to multiply it by to itself again. 12.944279191. Half AB times sine C. Okay, times sine C. So half AB sine C, that's sine of 36 degrees. And then I'm going to multiply that by 10. Okay, and we'll round our answer at the end. Okay, so now I don't want to lose that answer, and I might just show you something here. Probably not a bad idea to do this. I'm just saying, just suggesting perhaps. We can store that in a memory location. See that red letter there? I don't know if you can see that, just above the closing parenthesis there. Shift RCL, you see store up here, X. All right, and it puts that value there, so you don't have to type it out again. And it's a lot more accurate than using the answer key on the calculator, because this could actually go wrong if you're not careful with it. All right, so let's now work out the answer. All right, so half, okay, half AB, okay, but it's actually times X, all right, times X or X squared, okay, times sine of 36 degrees, multiply that by 10 of those triangles, and we get 492.429, okay, 0.429 and rounding it to correct to one decimal place, that's going to be 492.4 and square centimeters. Question 33. The graph shows the number of bacteria, Y, at time n minutes. Initially, when n equals 0, the number of bacteria is 1,000. So part A, find the number of bacteria at 40 minutes. And we'll just have a quick look at part B, so it follows on the next page. Part B, the number of bacteria can be modelled by the equation Y equals A times B to the power of n, where A and B are constants. Use the guess and check method to find, to 2 decimal places, an upper and lower estimate for the value of B. The upper and lower estimates must differ by 0.01. All right, so let's go back to the graph and part A. So it says find the number of bacteria at 40 minutes. So on the x-axis here, let's locate the 40. From there, just all the way, so it'll go all the way up vertically to the graph until you strike the graph, and then project across, and you see that number of bacteria is 4,000. So all you need to do is just write down 4,000. All right, let's have a look at the next part here. So back to part B. Okay. So we have the equation Y equals A times B to the power of n. Now the A represents the initial value. In other words, when n equals 0, B to the power of 0 is just 1, and therefore, A times 1 is just A. So A represents the value of Y when n equals 0, sort of another way to put it. So going back to our graph, okay, so n equals 0 means that's the initial sort of starting value, the initial number of bacteria, and that's going to be 1,000. So A equals 1,000. Hence, the equation is y equals 1000 multiplied by b to the power of n. Okay. Now what we need to do is to go back to our graph, because we need to estimate a value for b. Okay. We need to pick another point on the graph, and just pick a convenient point. It can be any point, but I might go back to the point that we initially found in part A, which was this point, 4,000 bacteria when n equals 40. So this here is a very convenient point to use. So we're going to substitute the coordinates of that point into this equation, and a bit of guess and check. Hopefully we can find a value for b, or at least narrow it down so that it's between sort of the two values, the upper and lower estimates by 0.01. So the difference between them. All right. So what we're going to do is we're going to use, okay, when, in fact, the best way to write it is that when n equals 40, okay, y is equal to 4,000. And in fact, that could be, or may be, a reason why part A is the way it is. It sort of gives you a clue that that's a very convenient point to use to help us with part B. Okay, so we have 4,000, okay, y is equal to 1,000 times b to the power of n, or b to the power of 40. So n is 40. When n is 40, the number of bacteria is 4,000. If we divide both sides by 1,000, just to sort of clean up the algebra, we end up with 4 is equal to b to the power of 40. Now, we're probably going to need a little bit of extra space here. I like to set this up a little bit first before we use guess and check, but you could use guess and check at this point here if you like, to save a bit of space. So I need to find a value for b, so when I raise it to the power of 40, I get 4. All right, this is where you need to spend a minute. Just try a few values on your calculator. So it has to be greater than 1, so I could try 1.1 to the power of 40, and we get 45, so it's clearly way too big. Okay, so we need it to equal 4. So when b equals 1.1, okay, y is equal to 45. So 1.1's way too big. Let's go back and try 1.01. That's way too small. Okay, so b equaling 1.01, y is equal to 1.49. Okay, we can try increasing that, say maybe to 1.05. Okay, we're getting closer, we're narrowing it down now. So b equaling 1.05, okay, y is equal to 7.0. Okay, and so on. So at this point, we'll probably get it pretty close. We've got 1.04. In fact, why don't we try 1.03 while we're at it? Yeah, there you go. So 1.03, 1.04. So when b is equal to 1.03, y is equal to 3.26, and when b is equal to 1.04, okay, and I might just go back to my previous answer, is 4.8. Therefore, b must lie between 1.03 and 1.04. Question 34. Tina inherits $60,000 and invests it in an account earning interest at a rate of 0.5% per month. Each month, immediately after the interest has been paid, Tina withdraws $800. The amount in the account immediately after the nth withdrawal can be determined using the recurrence relation. AN equals AN minus 1 outside of 1.005 minus 800, where n equals 1, 2, 3, and so on, and A0 is equal to 60,000. Part A, use the recurrence relation to find the amount of money in the account immediately after the third withdrawal. There's also a part B, so I'll just put that there as well. Part B, calculate the amount of interest earned in the first 3 months. Okay. So let's use this recurrence relation. Okay, and it's fairly straightforward to use. Let's start off with A0. A0 is the amount that we have initially, which is $60,000. Now, at the end of the first month, okay, we have our $60,000 to start off with from A0. It's going to have interest added, which is 1.005, which is an increase of 0.5%. And then Tina is going to withdraw $800. Okay, so 60,000 times 1.005 minus 800, and we now have 59,000. Well, actually, Tina has $59,500 in the account after the first month. So this is a recurrence, so we're going to do the same thing again. This time we're going to calculate the amount in the account, or the balance in the account after the second month. So it's a recurrence. We use what we had in the previous month, so we'll start off with that, 59,500. So that's like our principal for the month. Okay, we're going to multiply that by 1.005. So that's adding, the bank is going to add some interest to that, or pay some interest. Tina is then going to withdraw another $800. So this amount here, this 800, represents the withdrawal, the monthly withdrawal that Tina's withdrawing from this account. Okay, so entering in that amount, so 59,500 times 1.005 minus 800, and we end up with 5,897 and 50 cents. So $58,997.50. Now, end of the third month, so that's A3, is equal to whatever we have in A2, so that's 5,897.50. We're going to multiply that by 1.005 according to our recurrence formula there, our relation there. All right, Tina's going to withdraw another $800. Okay, so 5,897.50. Okay, multiplied by 1.005, and then we're going to subtract 800, and we end up with 5,8492. 5,8492.49 roughly. Okay, so it's rounded to the nearest cent. Okay, so I might just say it's sort of approximately equal to that much because we've had to round this value. Okay, so that's how much money's in the account after the end of the third month. Let's have a look at part B. Okay, so part B says calculate the amount of interest earned in the first 3 months. So this one's actually very straightforward. In fact, the only thing you really need to think about here is how much Tina has withdrawn already. And she's withdrawn 3 lots of $800. But even after $2,400 has been withdrawn, so 3 lots of $800, we have $58,492.49 in the bank. Okay, so let's see what the difference is, and that's in fact the interest that she's earned. In fact, so what we'll do is we'll start off with 5,892. So that's the amount that she has in the bank after 3 months. Okay. Let's add back in what she withdrew. Okay. And let's see what we get there. Okay. And 49 cents. So let's add the $2,400 back in. Okay. 60,892.49. Okay. Okay. I could have shown this 2,400 as 3 times 800, but I've explained that now, so you could write 3 times 800 there, that's fine. So the amount of interest then must be the difference between the original principal, so that's the $60,000, and what she would have had then in the account had she not taken the $2,400 or not withdrawn that. So, okay, so the interest, okay, is equal to 6089249 minus 60,000. Okay, and that's equal to $892.49. Now, just incidentally, if she had not withdrawn the $2,400, so I'll need to qualify my explanation here just a little bit, she would have earned maybe slightly more than $892.49. Remember that because Tina has withdrawn sort of some lots of $800 there, that actually reduces the amount of interest she's going to earn anyway. So all I was saying here is if you, whatever she has in the account, so it's almost like you're sort of pretending you're sort of adding back that $2,400, she would have $60,892.49, which is $892.49 more than what she originally started with, which was $60,000. Yeah, so which was the $60,000. So in the end, she made $892.49 in interest. Question 35. The intelligence quotient IQ scores for adults in City A are normally distributed with a mean of 108 and a standard deviation of 10. The IQ scores for adults in City B are normally distributed with a mean of 112 and a standard deviation of 16. So this question has three parts. So I'll just quickly go through those parts. So part A, Yin is an adult who lives in City A and has an IQ score of 128. What percentage of the adults in this city have an IQ score higher than Yin's? We go on to part B. There are 1 million adults living in City B. Calculate the number of adults in City B that would be expected to have an IQ score lower than Yin's. And the final part, part C, Simon, an adult who lives in City A, moves to City B. The Z score corresponding to his IQ score in City A is the same as the Z score corresponding to his IQ score in City B. By first forming an equation, calculate Simon's IQ score. Give your answer correct to one decimal place. All right, so let's go back to the beginning. Part A. Okay. Now, this is to do with the normal distribution. So this is the bell curve. Now you can use your formula sheet. Obviously, it's got the empirical rule. Now I've just hand drawn it here, so I've just drawn it manually. Okay, so I'll be referring to this, so you might recall this. When you're dealing with Z scores, and especially with normal distributions, anything sort of between -1 and 1 standard deviation from the mean, 68 or roughly 68% of the scores will lie between -1 and 1 standard deviation from the mean, or a Z score of -1 to 1. 95% of scores will lie from -2 to 2, and 99.7% of scores will lie from -3 standard deviations to 3 standard deviations from the mean. All right, so we'll refer to that later. All right, so let's go back to part A. Yin is an adult who lives in City A, has an IQ score of 128. What percentage of adults in this city have an IQ score higher than Yin's? Okay, so let's see, first of all, City A, let's go back to the question. City A, the mean is 108 and a standard deviation of 10. Okay, so let's work out Yin's Z score. Okay, and that's going to be equal to his IQ score, so that's 128. Okay, minus the mean or the average Z score. So again, for City A, mean of 108, so 128 minus 108 all over the standard deviation, which is 10. Okay, so you could work this out easily enough. So 128 minus 108 over 10 gives us a Z score of 2. Now, it's asking for what percentage of the adults in this city have an IQ score higher than Yin's. Okay, so let's go back to our bell curve or our normal distribution. Okay, so we've got a Z score of 2. Okay, so what percentage will that be? Okay, so 2.35 plus 0.15, right, that's going to be 2.5%. Okay. Okay, so okay. Next part, part B. There are 1 million adults living in city B. Calculate the number of adults in city B that would be expected to have an IQ score lower than Yin's. So now again, if we go back to our distribution, okay, so Yin's score, his IQ score is 128. So I'll go back to the question there. Okay, so his IQ score is 128. Okay, now we're dealing with city B, so mean of 112, standard deviation of 16. So what we're going to have to do is we're going to have to recalculate Yin's Z score for city B. It's not necessarily going to be the same as city A. In fact, it won't be. Okay. So let's do that first. So right, for city B is equal to his IQ, which is still 128, minus the average for city B, and for city B, mean of 112 over standard deviation of 16. Okay, so make sure that you put in the right, substitute in the right values into the Z score equation. Okay, and that's going to be equal to, okay, so 128 minus 112 over 16, and we get 1. That's a very convenient Z score. Okay, so if we look at our bell curve, okay, so there's our standard deviation of 1. Okay, now 50% of the data lies from 0 all the way to sort of negative infinity. Okay, but we're adding another 34% to 50%. So that'll be then the total or the percentage of adults that are under a Z score of 1. Okay, so okay, first of all, so from the bell curve or from the normal distribution, okay, you've got 50%, that's percentage of scores under 0, plus 34%, which is the percentage of scores from 0 to 1 standard deviation. Okay, and that'll be 84%, and therefore 84% of adults have an IQ less than Yin's. Now that doesn't quite answer the question. We actually want the number of adults, so 84% of 1 million, okay, is going to be equal to 840,000 adults. Okay. Right, let's go to the final part now, part C. Okay, Simon, an adult who lives in city A, moves to city B. The Z score corresponding to his IQ score in city A is the same as the Z score corresponding to his IQ score in city B. By first forming an equation, calculate Simon's IQ score and give your answer correct to 1 decimal place. So first of all, we're going to let A equal Simon's IQ score. Okay. You could use any pronumeral you like, so it doesn't really matter. I could use letter X. I didn't use the letter X, so not to confuse it with the mean. Okay, so the mean with the X with the bar on top. Okay, so what we're going to do is we're going to sort of form an equation. So, in other words, the Z score for both cities is going to be the same. So the way we're going to do this is we're going to say A minus the average for city A. So just bring back, make sure you might have to go back to this. It's on a previous page. So the mean for city A is 108, standard deviation of 10. Is equal to his z-score for city B. So A minus, now for city B, 112, standard deviation of 16. A minus 112 with A, standard deviation of 16. So we've now formed our equation. So these are the two z-score equations basically, but with the different values substituted in, okay, for both cities. And A is Simon's IQ. All right, so now we need to solve this equation. Okay, so from here, this point on, it's just algebra. So what I'm going to do is I'm going to cross multiply. So move the 16 over here. So 16, A minus 108 is equal to 10 outside of A minus 112. Okay, so notice that's a very quick way to eliminate the fraction, or to convert it from in fractional form to sort of linear form, okay, without the fraction. Expand the brackets, so 16A minus, now 16 times 108, so expand that, 1728. 1728 is equal to 10A minus 1120, so that's 10 times 112. Now let's collect the like terms, so 16A minus 10A is equal to negative 1120 plus 1728. So it's just the algebra really from this point on. 16A minus 10A, that's 6A. And negative 1120 plus 1728, and that's equal to 608. Now A is equal to 608 divided by 6. Okay, so divide that by 6, and we get 101 and a third, or 0.333. Okay, sort of it carries on there. And it says correct to one decimal place. Yep. Okay, so let's enter to one decimal place. So therefore, A is equal to 101.3. So Simon's. And that's it. Thank you for watching. Question 36. A cricket is an insect. The male cricket produces a chirping sound. A scientist wants to explore the relationship between the temperature in degrees Celsius and the number of cricket chirps heard in a 15-second time interval. Once a day for 20 days, the scientist collects data. Based on the 20 data points, the scientist provides the information below. A box plot of the temperature data is shown. There's your box plot. We have the mean temperature in the data set is 0.525 degrees Celsius below the median temperature in the data set. A total of 684 chirps was counted when collecting the 20 data points. The scientist fits a least squares regression line using the data, x, y, where x is the temperature in degrees Celsius and y is the number of chirps heard in a 15-second time interval. The equation of this line is y equals negative 10.6063 plus bx, where b is the slope of the regression line. The least squares regression line passes through the point x bar, y bar, where x bar is the sample mean of the temperature data and y bar is the sample mean of the chirp data. So this continues on the next page. Calculate the number of chirps expected in a 15-second interval when the temperature is 19 degrees Celsius and give your answer correct to the nearest whole number. There's a lot going on in this question. So let's work backwards. We want to work out or calculate the number of chirps expected in a 15-second time interval when the temperature is 19 degrees Celsius. Going back to our equation of the regression line, it hinges on this. We need to find the value of b, or the gradient of the line. Now, working backwards even further, in order to get or to calculate b, we need x bar and y bar. Now, x bar is the average temperature. Let's go to the box and whisker plot. One of the points here is, or the second point is, that the mean temperature in the data set is 0.525 degrees Celsius below the median temperature in the data set. So let's see what the median temperature is there. It's 22. So it's important that you understand how to read a box and whisker plot and know where the median is. So let's start off. So what I'm going to do is I'm going to write down that the median temperature is equal to 22 degrees Celsius. Now the mean temperature is 0.525 degrees Celsius below that. So let's write that down. So the mean temperature, which is equal to x bar, is equal to 22 degrees minus 0.525. Okay. And we get 21.475. So this is x bar that we will need to use in order to be able to calculate the slope of the regression line B. Okay, now the next thing we need to work out is y bar. And that's the average of the chirps, okay, or the sample mean of the chirp data, okay, in a 15-second interval. And the third point, so let's make sure we get the points, the number of points correct, first, second, third point. The third point will give us y bar. Okay, we have 684 chirps was counted when collecting the 20 data points. So let's work out the mean chirp data. What's the mean number of chirps actually in a 15-second interval? And that's in fact equal to y bar, which is equal to 684 divided by 20. Okay, so 684 divided by 20, and we get 34.2. Now, let's go to our regression line, okay, or the equation of the regression line. We know, and we're actually told, that the regression line passes through this particular point, x bar, y bar. Okay, so the regression line okay, I'll just write the equation again, just makes it easier. So it's y equals negative 10.6063 plus bx passes through the point 21.475, that's our x bar, and y bar is 34.2. Now we need to substitute this coordinate or this point into the regression line equation. So 34.2 is equal to negative 10.6063 plus b times x, or x bar, which is 21.475. Okay, so rearranging that equation, okay, we have 34.2. We're going to add on 10.6063. I'm going to put that in brackets. I'm going to do this all in one step. And then we're going to divide by 21.475. So this is just a little bit of algebra. 21.475. Okay, that's equal to our gradient. So therefore, B is equal to, okay, let's work that out now. So 34.2 plus 10.6063. Divide that by 21.475. And we get 2.086. I might just write the whole answer there rather than rounding it too early. 0.86440047. Now that we have the gradient of the line, we can now use this to, in fact, answer the question. So we want to work out how many, or calculate the number of chirps in a 15-second interval when their temperature is 19 degrees. So now at x equals 19, okay, we have y is equal to negative 10.6063 plus 2.086440047 multiplied by x, which is 19. Okay. So working that out, we have negative 10.6063. Now, the value for B is in the answer memory, so I'm just going to use that. So just be very careful using that to make sure that that's in fact the correct value that you have in there, as long as you haven't done any other calculation. Times 19, and we have 29.036. Now to correct to the nearest whole number, we have 29 chirps. Thank you for watching. Question 37. Wilma deposited a lump sum into a new bank account which earns 2% per annum compound interest. Present value interest factors for an annuity of $1 for various interest rates are, and numbers of periods n are given in the table. Wilma was able to make the following withdrawals from this account. So $1,000 at the end of each year for 20 years, starting 1 year after the account is opened, and $3,000 each year for 10 years, starting 21 years after the account is opened. And I think that's an important one there that we'll definitely have to see what we can do about that one. Okay, because that's a sort of a point of complication there, I guess. Something we need to think about a bit more carefully. Calculate the minimum lump sum that Wilma must have deposited when she opened the new account. Okay, so let's have a look at the first point here. So we've got $1,000. She was able to withdraw $1,000 at the end of each year for 20 years. So I might just write this out. It's $1,000. Okay, and she was able to withdraw that for 20 years. So we need to use this row here, the second row, 20, at 2% per annum. So the interest factor is 16.351 to give us $16,351. Now let's consider the second point. So this is the $3,000 each year for 10 years, starting 21 years after the account is open. So we're talking about the final 10 years of this sort of this investment. Okay, so we'll use the last row here for a moment. So that's going to be, let's call this sort of number one. Okay, so this is value number one. $3,000, okay, multiplied by 22.396, okay, is equal to 67,188. But that's actually incomplete because this assumes that we're starting that she's been withdrawing $3,000 right from the very beginning. But she didn't. She withdrew that $3,000 at, sort of from the 21st year. So in the final 10 years of the investment. So you've got to be careful with these tables. They assume that you're starting from the very beginning. In other words, n equals 0 or n equals 1, sorry, right from the very beginning. But she's starting from the 21st year. So we also need to sort of subtract this amount, the present value, the present value that we calculate at the 20th year, which is 16.351. Which is 49,053. Okay. So now to calculate the minimum lump sum, we take our subtotals 1 and 2. Okay. 1 plus 2, but we need to subtract out 3. Minus 3. Okay, so that's equal to 16,351 plus 67,188 minus 49053. And let's see what we get there. Okay, so 16,351 plus 67,188 minus 49053, and we get $34,486.